In this module here, I'm going to explain to you how to understand a graph. There are basically going to be 4 parts to this module. First, we're going to look at the basic parts of a graph. Then we're going to see how to determine the magnitude on a graph at a particular point. We're going to look at the slope of a graph. And finally, we're going to look at the area under the curve. To start, let's look at some of the basic parts of a graph. This is a pretty typical looking graph. First, we're going to have a horizontal axis, which is formally known as the abscissa and sometimes called the x-axis. It's important to remember, though, that this is the x-axis on the graph, and it is not going to be the x-dimension of your biomechanical analysis. You'll note here that on our horizontal axis here, we have the appropriate units, and then we are going to label that axis, and we're going to designate what those units actually are. Next, we have our vertical axis, which is more formally known as the ordinate, or also known as the y-axis. And again, this is the y-axis on our particular graph, and it is not the y-dimension in our biomechanical analysis. And just like what we did with the horizontal axis, we want to have particular units, and then we want to make sure that we label that axis and designate which units it is that we're talking about for that particular axis. Now, in this particular graph, we only have one tracing, so it should be pretty obvious about what's happening with this particular graph. But many times, we're going to have more than one tracing on a particular graph. In that case, we want to make sure that we designate which each tracing represents. That's going to be my box down here on the lower right corner, which is going to be referred to as the legend. And this clearly lets us know that the green tracing is going to be body A, and the red tracing is going to be body B. Now let's take a look at the magnitude. The magnitude is how large a particular value happens to be. So what we are going to do is we want to know what the magnitude is at a particular point. Well, the magnitude is simply going to be how far away from that horizontal axis that point rests. And if we have a different point, we can talk about how far away from the horizontal axis that particular point is. How do we determine that value? Well, first we'd want to drop a line down to the horizontal axis to let us know at what particular point we're talking about on the horizontal axis, which in this case here happens to be time. Then we'll draw another line to the left so that it intersects with the vertical axis. And then that will tell us how large the actual magnitude happens to be. Now let's look at slopes. If you've ever gone for a walk or ridden a bike or even driven a car, then you have an already intuitive understanding about what a slope is, because it's how basically the ground underneath of you is rising or falling. Well, it's going to be the same with a graph. First, if we were walking uphill, that would be referred to as a positive slope. If we were walking on level ground, that would be referred to as a zero slope. And if we were going downhill, that would end up being a negative slope. So an easy way to try and remember that when we're looking at graphs is to imagine yourself walking on the particular tracing. Going back to our standard graph here, you'll notice that our tracing is going to be a straight line. That means that our slope is going to end up being constant throughout the duration of the graph. Now, again, I was talking about visualizing yourself taking a walk on the graph. So if I'm walking along this particular graph right here, you'll notice that I'm going uphill. Since I'm going uphill, I'm going to have a positive slope, and because I have a straight line, that slope ends up being constant. Now, I could also be going downhill. And if I'm going downhill, I will have a negative slope. And again, in this particular case here, my tracing is a straight line. So since it's a straight line, that means that I have a constant slope, which in this case, because I'm going downhill, is going to be negative. Now, it's important to remember that with vectors, the positive or negative sign is only representing direction. And so a negative value is not necessarily going to be less than a positive value. In this case here, if we look at tracing A and we look at tracing B, we will note that at any point they are going to be equidistant from each other from the horizontal axis. That means that they have the same magnitudes at every point in time, they're just going in different directions. In this case, tracing A is going in the positive direction and tracing B is going in the negative direction. Now, if you've ever gone for a walk or ridden a bike or ridden in a car, you'll note that the gradient of the ground isn't always going to be the same. Sometimes it could be steeper and sometimes it might be flatter. Well, that steepness or flatness is going to tell us something about the slope. And a steeper gradient is going to designate a greater slope. So in this particular case here, tracing A is going to have a greater slope than tracing B. Now we can also have a situation where our slope is flat. This would be as if we were walking on level ground. And whenever our slope is flat, we're walking on level ground, that slope ends up having a value of 0. So far, I've talked about what happens when our slopes are constant. But what happens when our slopes are not constant? In this particular case here, if we were to walk on the slope, we would tell that we're going uphill. So we have a positive slope. However, we definitely do not have a straight line here, so that means that our slope is not going to be constant. In these instances here, when our slope is not constant, we can look at two different kinds of slope. The first one, easy enough, would be to put a point at the very beginning and the very end of the graph, and then draw a straight line connecting the 2 points. This is going to represent the average slope. The average slope would tell us what the slope would be if the slope were constant throughout the entire duration of the graph. But sometimes we're not interested in just the average slope, but we also want to know what the instantaneous slope is. The instantaneous slope is going to be the slope at a particular point. So if we look at our point here, what we would do is we'd draw a tangential line which just so happens to kiss the graph. That is going to represent our instantaneous slope. If I have another point and I draw another tangential line that just kisses the graph at that particular point, that would represent the instantaneous slope at that particular point. And note here, because my slope is not constant, that those instantaneous slopes are going to be different at different points on the graph. This is another tracing which also represents a positive slope, but again it's going to be a non-constant slope. I will ask you in our breakout sessions to be able to draw the average slope as well as the instantaneous slope on a couple of different points on this graph. Now here I put all 3 tracings together on the same graph. I hope you can appreciate that for all 3 of these tracings they are going to have the same average slope. You will prove this to yourself within our prep guides. Now, even though all 3 of these have the same average slope, the instantaneous slopes will be different at different points on the graph. Next, we're going to look at the area under the curve. If we look at a particular tracing and we were to shade in the area in between the tracing and the horizontal axis, that's going to be our area under the curve. And it doesn't matter what the shape of the curve is, all we have to do is just fill in the area between the tracing and the horizontal axis, and that's going to be our area under the curve. And again, we just fill in the area between the tracing and the horizontal axis, and that's going to be our area under the curve. Now, if we look at the areas under the curve for each of these 3 tracings, we will see that even though they have the same average slope, they're going to have very different areas under the curve. The blue shaded area represents just the area underneath the blue curve. The red curve, however, is going to have not only the area that's shaded in red, but also the area that's shaded in blue. If we go back for a sec, I hope you can appreciate that. And finally, the area under the green curve is not only going to be the green shaded area, but also the red shaded area and the blue shaded area, which if we go back and look at, you can see here. So this shows you that all three of these graphs, again, even though they have the same average slope, we're going to have different areas under the curve. So in this particular module, we took a look at the basic parts of the graph. We determined how to find the magnitude at a particular point on that graph, both the average as well as the instantaneous slopes, and the area under the curve.